Alright, ladies and gentlemen, welcome back to your video notes for Chapter 6 in your McGraw-Hill Geometry textbook. These are the video notes for Chapter 6, Section 4, which is entitled Rectangles. We have spent two sections discussing parallelograms, and now we are moving on to discuss types of parallelograms. And we start with rectangles. So, rectangle is defined as being a parallelogram, specifically, with four congruent angles. Now, that means that if I were looking at this picture and we called this A, B, C, D, that I could go in here and say, okay, well, if all four of these angles are congruent, they are all right angles because the sum of the interior angles in any quadrilateral is 360 degrees, as discussed earlier in the chapter. And if there are four angles, a total of 360 degrees, then 360 divided by 4 would give us the measure of each individual angle, where they would each be a 90-degree angle. Now, we've dealt with rectangles all the way through. You've learned about rectangles before. This is not a new shape for you. But what's going to be the complication here, what's going to be difficult, is this definition now, where we're saying a rectangle is in fact a parallelogram, and we start there. We don't say a quadrilateral with four equal angles. We say a parallelogram. And the problem is going to be that you need to understand that that means that every rectangle starts off with the properties of a parallelogram. So the fact that this rectangle is in fact a parallelogram means that automatically that means that AB is parallel to CD, AD is parallel to BC, because in every parallelogram, opposite sides are parallel. We can also immediately state that the length of AB is equal to the length of CD, i.e. they are congruent line segments, as are AD and BC, because again, opposite sides in a parallelogram must be congruent. Now, not all of our parallelogram properties are that useful. The diagonal one is occasionally useful, that is that AC bisects, probably would help if I could spell it well, AC bisects segment BD and BD bisects AC, because the diagonals of all parallelograms bisect each other. But the other two, they're not as useful. Okay, we know that angle A is congruent to angle C because opposite angles are congruent in every parallelogram, but we already knew that because all four angles are 90 degrees. We also already knew that angle A, or that every pair of consecutive angles, is probably the better way to phrase it, every pair of consecutive angles adds up to 180 degrees. Every pair of consecutive angles are supplementary. That one also is kind of like a duh moment when we state that all of them are 90-degree angles. Then of course any two consecutive angles would add up to 180 because they're both 90. 90 plus 90 is 180. Same thing would apply if I looked at A and B. 90 plus 90 is 180. So those last couple, they're not as useful, but you need to keep that in mind, that when we say something is a rectangle, that means it is a parallelogram as well, which means it has all the properties of a parallelogram plus a few extra properties that apply to rectangles but not to parallelograms. So keep that in mind. Now let's look at what are the properties of rectangles specifically. These are the ones that are true for only rectangles, not parallelograms. And those are as follows. Number one, the diagonals don't just bisect each other, they are also congruent to each other. So not only do the diagonals bisect each other, they're also congruent. Number two, in every rectangle, the consecutive sides are perpendicular, which should not come as any surprise to us if we know what the word perpendicular means, because perpendicular means intersecting at a 90-degree angle. So if we went back and looked at this rectangle here, it should make sense to us that AD is perpendicular to AB because those two sides form a 90-degree angle, and that's the definition of the word perpendicular. Finally, a rectangle is the only type of quadrilateral where consecutive angles aren't just supplementary, they are also congruent. They are both 90-degree angles. So they're both supplementary and congruent. So we're going to do a lot of problems here where we are confirming that something is a rectangle, or we're using the fact that it's a rectangle to set up and solve an equation. So here, this first example is a word problem that I adapted from your textbook. It says that PQRS is a rectangle. In that rectangle, PS is 180 meters, PR is 200 meters, and we're asked to find these measures. So the first measure we're asked to find is QS. Well, in the picture, QS is one of your diagonals. The other diagonal is PR. And because this is a rectangle, we should know that QS and PR are equal because the diagonals of all rectangles are congruent. So there's our reasoning. Well, if QS is equal to PR, that means that QS is equal to 200 meters, and the problem is complete. Now, finding PT is a little bit more difficult, especially since I didn't include the T. So the T is supposed to be this intersection point here, okay? So T is where those two diagonals intersect. If we're asked to find the length of PT, and we know the length of PR, that should not be very difficult because it's not a rectangle property, but we should be aware that QS is bisecting PR because it is in fact a parallelogram. And if QS bisects PR, then PT is equal to exactly half the length of PR, which means that PT would be 1/2 of 200 meters, meaning that PT is 100 meters. So using these properties is not always super straightforward. We need to understand that every rectangle is a parallelogram, but not every parallelogram is a rectangle. Okay, so let's look at some more. Here's another problem that is a rectangle. It says quadrilateral JKLM is a rectangle. If the measure of angle KJL is 2x plus 4, so let's mark that angle. KJL, that's this angle right here. So this angle right here is 2x plus 4 degrees. And the measure of angle JLK, that would be this angle right here, is 7x plus 5. It says find the value of x. Well, the other piece of information that they've given us here is that this is a rectangle. JKLM is a rectangle, which means angle JKL, this angle here, has to be a 90-degree angle because this is a rectangle. And then from there, we have to reach back and recognize that the diagonal JL creates a triangle in this picture. And we have to be able to state that the measure of angle KJL plus the measure of angle JLK plus the 90-degree angle, which is the measure of angle JKL, those three angles together form a triangle, and all triangles add up to 180 degrees. So plugging in what they give us in the directions, we have an equation. 2x plus 4 plus 7x plus 5 plus the 90-degree angle equals 180. Once we have an equation, which is 90% of what geometry class is setting up an equation and then solving it, we should be able to solve that equation by combining like terms. So we've got 9x plus 99 equals 180. And then solving that equation. Well, that's a two-step equation. We would start by subtracting 99 from each side of the equation, which would give us 9x equals 81. And then we would divide by 9 to get x by itself. Well, when we divide by 9, we get x equals 9. Our final step then is an SAT practice skill. We need to make sure we answered the question. The question was find the value of x. We did that. We are done. In addition, we've also still got these coordinate problems that were introduced in 6.3. We are able to tell whether or not a quadrilateral is a rectangle by checking to see whether or not it has the properties of a rectangle. So in this case, we won't be using the midpoint formula on problems in this section, but we could do that with either the distance formula or the slope formula. So if we're asked to determine whether PQRS is a rectangle using the distance formula, again, keeping in mind that the distance formula is x2 minus x1 quantity squared plus y2 minus y1 quantity squared underneath the square root. What we're really going to be doing is we're going to be checking to see, are the diagonals congruent? And it's worth noting that I'm not going to give you a quadrilateral that's not a parallelogram, so I probably should have said parallelogram PQRS has vertices at. And then that way you don't have to check that, okay? I'm expecting you to check and see if it's a rectangle, which would imply I'm giving you a parallelogram and I'm saying, is this parallelogram more specifically a rectangle? So let's graph those points, -5, 3, 1, -1, -1, -4, and -7, 0. Okay, so we connect our dots to get our shape. I'm wishing that was in blue, so I'm going to redo it. There we go. Okay. So there's our shape, and we're going to label it. So we have P, Q, R, and S. So what we're checking is we're checking to see whether or not PR is congruent to SQ. Now again, I've changed the directions to state parallelogram PQRS, and the reason I can do that is if you quickly check the slopes, you'll find that PS and QR both have a slope of 3/2, meaning they are parallel, and PQ and SR each have a slope of -2/3, which shows that they are parallel. So we're checking to see whether or not the diagonals are congruent. So we're going to start by finding PR. Okay? So we're going to go in here and we're going to say P is going to be x1, y1, R is going to be x2, y2, and we are going to plug into our distance formula. So x2 minus x1 would be -1 minus -5, which really becomes -1 plus 5, quantity squared, plus y2 minus y1 would be -4 minus 3, quantity squared. Again, that's something you should be able to feed into your TI-30XS2 multi-views. Your calculator should be able to give you the reduced root answer. Now, if you don't have that calculator, still not a big deal. Just reduce this down to where it's a single number. You should have -1 plus 5 is 4, quantity squared is 16, plus -4 minus 3 is -7, squared is 49. 16 plus 49 is 65, meaning that this is equal to the square root of 65. Then we are going to turn around and we're going to do the same thing for QS. We're going to check to see if QS has that same length. So Q would be x1, y1, S would be x2, y2, and we would plug into our distance formula. So again, that's x2 minus x1, which is -7 minus -1, quantity squared, plus y2 is 0, minus y1 is -1. So that would be 0 minus -1, which would end up being 0 plus 1. Again, that is -6, or I'm sorry, that should be -7 minus 1. That is a mistake on my part. Let me fix that. This should be a minus right here. Okay. So x2 minus x1 would be -7 minus 1, quantity squared. That would be -8 squared, which is 64, plus 0 plus 1, quantity squared, would be 1. So 64 plus 1, that also is the square root of 65. So because these are the same, what that's telling us is that PR is congruent to QS. The diagonals are congruent, which means the answer to this question is yes. Parallelogram PQRS could more accurately be called a rectangle. All right, our last slide then for today is another one of these questions, only this time it asks us to use the slope formula. Remember that two lines are perpendicular if their slopes are negative reciprocals, meaning they multiply to equal -1. Okay, so like for instance, if we had slopes on the last problem, we said we had slopes of 3/2 and -2/3. Well, 3/2 times -2/3 is -1, which means those two sides would be perpendicular. So what we're saying is we need to check those perpendiculars. So the first thing we need to do is graph. Let's start by graphing. We've got J is at -10, 2. K is at -8, -6. L is at 5, -3. And M is at 3, 5. So we graph those and we connect the dots. Okay, and label. So we have J, K, L, and M. And in order for us to guarantee that this is a rectangle, we would need to show that JK is perpendicular to KL. We would need to show that JK is perpendicular to JM. We would need to show that JM is perpendicular to ML. And we would need to show that ML is perpendicular to KL, which we can do if we simply find the slopes of all four of those sides. So we're going to check these one at a time. So we'll start with the slope of JK, which means J is x1, y1, and K is x2, y2. And we would plug into our slope formula. Remember, the slope formula is y2 minus y1 over x2 minus x1. So that would be -6 minus 2 over -8 minus -10, or -8 plus 10. So that would be -8 divided by +2, which is -4. Now, from there, we're going to go to the next piece, which would be the slope of KL. And we need to keep in mind that if the answer to this question is yes, we should already know what value to expect here. If these two line segments, JK and KL, are perpendicular, then their slopes will multiply to -1. Since JK is -4, KL would have to be +1/4. So we go in here and we say, okay, we're going to do KL. So this K is going to be x1, y1, L is going to be x2, y2, and we're going to plug into the slope formula. That would be -3 minus -6 over 5 minus -8. And almost right away we should realize that is definitely not equal to 1/4. Right there, we can stop. These do not multiply. Okay, -4 times 3 over 13 is not equal to 1, -1. Which means the answer here is no, because that means that JK is not perpendicular to KL. And if JK is not perpendicular to KL, that means this is not 90 degrees, which means this is not a rectangle. Now please keep in mind that if the answer to that were yes, if those did multiply to -1, you would have to keep going. You'd have to find the next side length, which would be what? JM, and JK and JM would have to multiply to -1. Then you'd have to find ML, and ML and JM would have to multiply to -1. All four of these have to be true for the answer to be yes. If any one of them is false, then the answer is no. Okay, folks, thank you very much for your time and attention. That does it for this section's video notes. There will be additional videos down the road for 6.5 and 6.6. Email me if you have any questions. Thanks again.